Welcome to the video lesson 6.3, Solving Compound Inequalities for Algebra 1. So, our last two sections, we are looking at the idea of inequalities, less than, greater than, less than or equal to, or greater than or equal to. Now, today we are going to start with looking at the idea of a compound inequality. That would be two inequalities joined by either an and or an or. So on the left here, you see the example for an and inequality. That would be, for example, here, saying x is greater than 0 and x is less than 4. So we could read that as x is greater than 0 and x is less than 4. Or we could read it as x is less than 4 and greater than 0. So the idea of an and statement is to isolate the variable in the middle, meaning the only thing we want in between our inequalities is a single variable. Now, the way we graph those, we still use open or closed circles the same way we did in the last two sections. But in this case, for an and, if x is greater than 0 and less than 4, I have my open circle at 0 and an open circle at 4. Then for any and statement, you are simply going to connect the two circles and shade the area in between. That means x could be anywhere greater than 0 and less than 4. The other type of compound inequality is an or. That would be, for example, this right here. X is less than 0 or x is greater than 4. So in any or statement, we're going to end up with two rays or two arrows for your answer. So if we're looking at graphing the or statement, we just graph them separately. X is less than 0, open circle at 0, arrow going to the left. Or x is greater than 4, open circle at 4, arrow going to the right for greater than. So looking at a few examples and how we go through the process to solve these. Now, for the and or the ors, the math is the same as the last two sections. So what you want to keep in mind is that we are working the order of operations backward, and we always want to isolate our variable, meaning get the variable alone. Now, the difference is, for an and statement, instead of doing math on both sides of the inequality, you have to do the math on all three parts. So what I mean by that is, looking at A, our goal is to isolate the inside. So we want to get rid of the minus 8 from this expression, 3x minus 8. So what I have to do is in the middle add 8 and add 8 on the left and the right of the inequalities. So what that becomes is 6 is less than or equal to 3x, which is less than or equal to 18. Now I need to get rid of the 3 that's being multiplied by x. So I'm going to divide the middle, the left, and the right all by 3. That gives me the final compound inequality. That is, x is greater than or equal to 2 and less than or equal to 6. So in this case, I need a filled in circle at both 2 and 6, and because it's an and, I'm going to just shade in between the 2 and 6. For an or statement, you just solve the two inequalities separately. So in B, we have 3x plus 1 is less than 4, or 2x minus 5 is greater than 7. So I'm starting with the 3x minus or plus 1 is less than 4. So to get rid of the additional 1, subtract 1 from each side. 3x is less than 3. Divide both sides by 3, and x is less than 1. Then we have to solve the other inequality. So add 5. So 2x is greater than 12. Divide both sides by 2, and x is greater than 6. So our final inequality here is x is less than 1 or x is greater than 6. So I have an open circle for both, and then less than 1 would be to the left, greater than 6 would be to the right. So we have the two different rays for our answer. Now with C, I apologize, the first one had its original inequalities going the wrong way, and it's actually not solvable. So you can cross off that first one and rewrite C to start as negative 2 is less than negative 2 minus x, which is less than 1. Or we could read it as negative 2 minus x is greater than negative 2 and less than 1. So now I need to get the negative 2 back to 0, so I'd add 2 to all three parts. So on the middle, in the side, I still have a negative x, or an opposite of x. On the left is a 0, on the right is a 3. Didn't do anything to the inequality symbols except for bring them down. Now, to get rid of the negative from the x, every part gets divided by negative 1. Remember, if we're multiplying or dividing by a negative, you have to flip the inequality symbols. So in this case, 0 is greater than x, and x is greater than negative 3. Or we could read it as x is less than 0, and x is greater than negative 3. So open circle at 0, open circle at negative 3, and draw the line connecting the two, meaning x is somewhere in between. Now D, we have an OR statement, so I need to solve my two inequalities separately. So with the first part, subtract 7 from each side, then divide by 2, and we have x is less than negative 2. Or, on the other one, subtract 5 from each side, then divide by the negative 5, meaning we have to flip the inequality, and that becomes x is greater than or equal to a negative 1. So in this case, an open circle at the negative 2, because it's purely less than, and then a filled in circle at the negative 1 with the arrow going to the right for greater than or equal to. And then we have our last two examples for today. E is another OR statement. So in this case, 15 minus 7x is less than or equal to a negative 6, or 6x minus 3 is less than or equal to a negative 6. So in this case, we need to solve them separately. So subtract the 15 from each side. Negative 7x is less than or equal to negative 21. Divide both sides by the negative 7, so we have to flip the inequality, and x is greater than or equal to 3. On the other side, we have to add the 3 to each side. After we add the 3 to each side, we're left with 6x is less than or equal to a negative 3. Divide both sides by 6, and a negative 3 divided by 6 is a negative 1/2. So x is less than or equal to a negative 1/2. Both can equal to, so both are filled in circles. Left for the negative 1/2, right from the positive 3. And then our last example for today, we have 6x minus 1 is greater than -7 and less than 5. So we have to get x alone in the middle. So we add the 1 to all three parts. Then a -6 is less than 6x, which is less than 6. Divide everything by the 6 to get x alone. And x is greater than -1 and less than +1. Open circles at each and connect in between because it's an and, not an or. And that is it for the graphing.